So we're gonna repeat a little bit of what we said here because I've already touched on some of these the Messier. So what we're focusing on for Messier minutes this time around is the more westerly of the summer objects that we're going to tackle first, and then we'll be back in a month, and then we'll get sort of deeper into the summer Messiers as we get farther in. So the first one we're going to look at is Messier 9, which is an Ophiuchus. So Ophiuchus is this sort of Dalek-shaped constellation that's sitting over the southeastern horizon in late evening nowadays, above the Milky Way. And M9 is kind of down in this leg that sticks down below this lowest star named Sabbath. So M9, let's bring up the eyepiece view here. You can see it's, kind of smallish. So it's too small to be seen really in binoculars, but really any size of a telescope will work on it. It's quite low in the sky, so it's actually been dimmed a little bit because of that. And it's also been dimmed because it's relatively near the Milky Way. See how it sits just, in the galactic bulge sort of area? So that's the dust and gas in our galaxy has caused the globular to be dimmer than it really should be. It's about 25,800 light years away. And as I said, you can actually, if you can find the star Sabbath, then it's about 3.5 degrees south of that. But the other way of doing it is to connect the star Chi Serpens and Antares. And you can see that M9 is sitting on that line. So you can sort of find that line and then drop a perpendicular below Sabbath, and you should be able to pick it up if you're using binoculars or a low magnification eyepiece. When you're looking at it, see if you can notice that it's a bit squashed. It's not round. It's a little bit distorted that way. And there are also some other objects nearby. So there's another globular sitting just to the left of it here that you can pick up while you're in the neighborhood. There's another one. I think it's below. Yeah, there's a couple more around. So enjoy that. All right, next up, we have M10. Now the body of Ophiuchus has a nice big bright globulars inside, and M10 is on the center line. So if you look at the peak of his head and then the center of his body, make that imaginary line, M10 is kind of on that center line. M10 here is, you can see it's bigger already than the M9 was. It's 12 arc minutes in diameter. Its magnitude about 7.7 or so. Again, a little small, sorry, here we go, magnitude 6.4. It's can be seen with the unaided eyes if you're in a dark site with the moon not around bothering you. You can certainly see it in good binoculars. You can see it any size of a telescope. If you've got a bigger aperture, you can see that the halo extends beyond here. So a bigger aperture will let you see more of the fainter halo around it. It's about 14,400 light years away. And as I said, if you use the center line idea between Razelhage and Sake, it's closer to the bottom than the top. Gotta have any other tips for you? You can make a right angle. So if you find the corner of Ophiuchus, drop down to Sake, and then go 90 degrees by about the same distance, that's another trick you could use to pick it up. And you can look for whether it's symmetrical. You can look for patterns in the brighter stars. So you can actually pick up some, chains and groups of stars in it as well. Next up is M12. M12 is its neighbor inside Ophiuchus. I'll bring up the view in the Dobsonian. You can see it's about the same size, but it's kind of more concentrated, a little bit brighter. So it's medium bright, medium sized, 16 arc minutes across. It's this is one's going to be visible in binoculars and any size of a telescope. You can actually share the view with M12. M10 and M12 will share the view in binoculars together at the same time. If you've got a bigger telescope, you can actually resolve nicely the stars in the halo and get quite deep into the core with a larger aperture telescope. So you get lots of benefits from that. Let's see. So to find it, what I suggest, so if you've already found M10, you can, slew a little bit up west and see it there. Or I find it between Kappa, Ophiuchus, and Sig. So there's Kappa, Ophiuchus, and Sig. So that's this one here. So if you start at the bright star Cybele and go to the corner, it's on that corner line. So that's one way of doing it as well. Or you could drop another one from Kappa, this top corner, down through Sig. So it's kind of along the intersection of those various lines. You can do it that way. Let's see what else to look at. If you're going to look at it, so Stephen O'Meara claims that there's kind of a rocket ship-shaped asterism of stars nearby. I'm not sure what he means. Maybe he means this, but pay attention to that sort of thing when you're looking. All right, just a couple more here. M14 is up next. So M14 is on the just outside the body of Ophiuchus. So M14, you can see it's brighter already, even though it's relatively small. It's fairly bright. It's 30,300 light years away. That's what makes its diameter rather small, but it has a lot of oomph to it. So binoculars, really, or any size of telescope should pick that one up, maybe even your unaided eyes. Now, interesting, the photographic plates taken by Helen Hogg in 1938 were later reviewed in the 60s, and they discovered a nova on that plate inside this globular cluster. And it's the first nova ever imaged. So that's kind of a neat one. Let's see. To find it, a couple of tricks you could use. So I've got it halfway between Razzle-Hagg and Chi Serpens. So that star Chi Serpens that I mentioned a minute ago. You go up towards Razzle-Hagg, it's halfway between those two stars. So if you can find those two stars, just aim halfway between them and you'll pick it up. When you're looking at it, also look for, there's a couple of other globulars. There's NGC 6366, a few degrees to the southwest, kind of in here. So you can take a look for that. All right, next up is M107. So M107 is down here below the body of Ophiuchus. And again, if you can find the star Sig, it's just a few degrees below that. So that's pretty easy. In a telescope, you can see it's pretty small. So it's more diffuse, less bright. So it's less bright, it's smaller. It's not really a binoculars object, but if you want to try for it, you want to try looking when it's highest in the sky, which is sort of after midnight. Let's see, it's for reference, it's sitting right above Antares. So that's kind of, you can look above Antares for Sig and then find the star there. The surrounding stars form a crucifix. So you can see there's a star here, a star here, star here, and then a couple stars here, and it makes a crucifix. And in a reflector telescope, those flip around. So the long arm of the crucifix will be up, down, inverted, like that. That's kind of a neat thing to look for. Again, so when you're looking at it, notice that its core density is less and it's got a little more dimension to it that way. Okay, next up, M4. Our friend M4 that we got all the awards. So M4 is dead easy to find. It's just sitting here to the west of the star Antares. Huge, bright, not as concentrated, really easy to find. You can see it with your unaided eyes, especially when it's highest in the sky, so after midnight. Binoculars work, telescopes work. It's been reported that it has kind of an internal bar structure, maybe a shape to the core, and some chains of stars extending beyond it. So you can look for those sort of fuzzy fur around it. It's among the closest of the globular clusters. That's really an award-winning one. And M80, let's go with M80 here. M80 is above Antares and M4. And what's neat is that a few of these, you can use the claw stars of Scorpius to find. So M80 is easy because if you go halfway from Antares to the highest claw star, A crab, it's halfway along. So that's an easy one to find. And again, it's really concentrated. See how bright it is? The M80 is medium bright. Any telescope will work. Really dense, 32,000 light years away. And make note of that density gradient and looking for it. And also you can be, and you're in that, while you're in that neighborhood, you can look for the Rho Ophiuchi reflection nebula complex sitting to the lower left. M19, where's M19? Here we go. M19 is here. M19 you can use by, you can find by taking the lowest claw star named Fang and doubling its line through Antares, and that'll put you right on M19. So that's easy. This one is a bit more diffuse, a little fainter. So it's large, but it's faint, and it's also been dimmed by the galactic dust and gas. If you're going to try it in binoculars, wait until it's higher in the sky, sort of 1 a.m.-ish. And if you've got a bigger aperture telescope, you can pick up lots of neat details, patterns of stars, and resolve the core, which is really nice. This is also the one that's got the outer round shape and the comet-like shape. So the core is, the center of the core is offset from the center of it. And there are other globular clusters nearby. There's one little smaller one here and a little smaller one here, all within a couple of 1.5 degrees of it. I think our last one is M62. M62 is in the same neighborhood. It's just sitting here below that. And M62, same trick. Take the middle star of the claw, go through Antares and roughly double that, and that's where you're going to pick up M62. I hope you're making notes, Samantha. This is all your tricks for finding these. Really helpful.
I can always come back to this video. So
this one's medium bright, medium sized, quite dense. So let's bring up the view. Let's see the density profile here. 22,300 light years away, and is one of the closest globular clusters physically to the center of our galaxy, the galactic core, which is in here. So that's actually, dimmed it more than it should be. You can pick this one up in binoculars, especially when it's highest. And this is one that has a black hole, confirmed black hole inside of it, so that's neat to know. And big telescopes will show you some of its nice structure. So it's really got some structure. Stephen O'Meara has reported a blinking effect. So the idea when you look at it with direct vision versus averted vision, it seems to brighten and dim. So he's nicknamed it the flickering globular cluster. So again, this one's not perfectly round. And yeah, so look for those sorts of things when you're looking at these objects. And that's it.
So that ends our Messier minutes. If anybody has any questions, I know we are right at 5 o'clock right now. Just a reminder that in the summer, we go down to 1 episode a month. So that's June, July, and August. So this has been our June episode. Our next episode will be on July 5th. And you can see our schedule on ras.ca/insiders guide that has our next topics coming up. However, we might change the next one to make it a little bit more themed. I'm excited. Chris told me about his article coming out in Sky News, and I want to hear more about it. So
yeah, keep an eye on your mailbox. The July-August Sky News, I wrote about celestial objects with Canadian connections to celebrate Canada. So we might highlight some of those.
So thank you all for coming. And as I said, all these materials, I've already put it in the chat. You can find all the list of our Messier objects at ras.ca/Messier-minutes, and also a playlist of just our Messier minutes in there as well. And don't forget, the RAS General Assembly is coming up. Tickets are on sale now, and I hope to see all y'all there. And you might maybe be able to get to chat with Chris or attend one of his presentations as well. Thank you all.